Hello, everyone. Good afternoon. My name is Parinita Rahi. I am from the Microsoft AI Frameworks team within the Azure AI Platform organization.
Hi, everyone. My name is Razvan Tanase. I'm an engineering manager in the Azure Machine Learning team under AI Platform.
And today, we are here together to talk about the Azure container for PyTorch. So this is a better together story with how PyTorch works great with Azure. So the Azure container for PyTorch is meant to solve three key problems. One is for researchers and scientists. How do they, don't worry about the setup times and, which package is compatible with which other version that is required for their large training workloads. So, we test and we pre-install and validate packages that are required for typical deep learning workloads for your training workflows. And then it's also meant to optimize training time. So it comes pre-installed with Microsoft's open source technologies that has accelerators that help speed up your model training time. And then it is integrated within the Azure stack, so you can use it easily within AzureML SDK, within the CLI, or the AzureML Studio.
OK, so now let's see what this Azure container for PyTorch is really about. In essence, it's an optimized training framework, which is useful to ease the setup and development of PyTorch model training. Besides that, it comes with the latest versions of Ubuntu, Python, PyTorch, along with device drivers that are optimized to perform on Azure hardware. Besides that, it comes with a bunch of accelerator technologies that are meant to speed up the model training, such as Onyx runtime for training, DeepSpeed, Onyx runtime for a mixture of experts, and OpenMPI. All of these are validated and tested against multiple first-party customers that are within Microsoft, and we guarantee that these will be working perfectly for third-party customers as well. Besides all the training packages that are meant to speed up, this Azure container for PyTorch is also useful for the experimentation phase of deep learning, which means that it comes pre-bundled with a bunch of profilers, like PyTorch Profiler, PySpy. It has integration with TensorBoard, so data scientists can monitor the model training phase and whatnot. And besides that, it is also backed by Azure customer support. I can go over some of the details for the container. So the Onyx runtime is used for both speeding up the inference and the managed training. At the same time, DeepSpeed is one open source deep learning library that is meant to speed up training, and it's shown that it's useful for training billion parameter models or even trillion parameter model in near linear scale. The Azure container for PyTorch is available in two flavors. First of all, the most lightweight option is a curated environment in Azure Machine Learning Workspace. And second of all, it's available as a VM image as part of an Azure Data Science VM, or DSVM as we call it in short. Curated environments represent a managed asset that is versionable and allows customers to have transparency, trackability during their ML lifecycle process. DSVMs are useful for, DSVMs are one way for customers to get an entire OS image which bundles data science specific tools. Besides the model training, also tools for visualization and many more.
Yeah, so to add to that, I think the curated environments help you enable reproducible, auditable, and portable machine learning workflows, so you can repeat, view your tasks, your training jobs, and repeat them with changing certain parameters, et cetera, very easily. So it helps scale out for organizations who want to reuse their training workflows over and over again, and has versioning support and other similar properties. So this is an example where how when we use the Azure container for PyTorch and include with it the deep speed acceleration technology and the Onyx runtime training capabilities, the gains that we see in terms of the samples per second or the training time. So here, this was run against the Hugging Face models like Roberta Large, GPT-2, Bloom models, and Distilbert. And the green lines are when it's run just with PyTorch. The orange is when it's run with PyTorch plus Onyx runtime or ORT. And the blue is when it's run with PyTorch, ORT, and deep speed. And you can see the huge jump in terms of the training time improvements. We see like 39 to 103% faster training times when these powerful acceleration technologies are combined and run with PyTorch on Azure. So here are some customer examples of folks who have tried ACPT and the capabilities included within. The first one is Bing. So Bing runs its ads language representation model that is served over 130 markets. And these are transformer-based models using billions of parameters. And they use it both for continuous pre-training and fine-tuning. And with overcoming resource limitation and speeding up training productivity are key objectives. And so when they use ACPT with deep speed and ORT combined, they see anywhere from 1.3x to 2.4x speed up in their training times. The other one is a third-party customer we have, which is a small startup which works on AI algorithms that help generate original clothing designs and help fashion companies meet customer demand and get to market faster. And so with smaller sized organizations, resource is a big challenge. Time spent in setup and all of that, the easier we make it for those customers, the better it is. And so in their distributed data parallel implementation, they were able to use ACPT effectively to gain their objectives. There is a blog available for this on the Azure website. I can link it out later. And another internal Microsoft team that used ACPT is the Microsoft AI Cognitive Service team. They build state-of-the-art computer vision technologies for next generation framework for visual recognition. And they're able to use ACPT to run scale jobs over hundreds of GPUs. And were able to do it efficiently. And like that, again, helps most of these research teams focus on the research work without having to worry about, how do I integrate all of these various libraries and components and keep up with the new versions that are coming up and the new versions of PyTorch that are coming up.
OK, so now let's look how the entire PyTorch stack on Azure works. So at the bottom of the stack, we have the hardware layer, which contains most up-to-date, most powerful GPUs that are available in the market, like NVIDIA A100s or NVIDIA V100s, which are interconnected with speedy InfiniBand interconnects. On top of that, we have the next layer, the software layer, which our recommended way is the ACPT container, which bundles a bunch of training optimizers like Onyx runtime, deep speed, SQL, and it has the pre-validated versions of all of these components that are guaranteed to get the most optimal performance for customers. All of these can be used with multiple entry points, such as the AzureML SDK or the command line interface, or simply from the AzureML UI. Customers can come and choose and integrate at any layer that they want from the stack. So they can either use our pre-built curated environments, or they can build their own custom solutions, which might be tailored for their needs. We have many customers that are using this internally, like Parinita just mentioned, the Bing, Microsoft Office, and at the same time, cognitive services. The benefit for the end customers is that they would get to use the same technologies that have been battle tested by first-party customers against planet-scale workloads.
So next up, we have a demo on how easy it is to use ACPT within AzureML. For this demo, we'll show you a Distilbert fine-tuning model from Hugging Face. Let me see. How do I, it's not playing. Okay. So in this demo, we'll cover 4 aspects. One is how do you create a curated environment and a custom environment within AzureML. And we'll show it specifically within the studio, but you can do it through CLI and SDK as well. And then we will show you how you can train a custom environment using the custom environment that we built with ACPT. How can you train the Hugging Face Distilbert model? And then if you were to compose it with deep speed and ORT, what are the training time gains that you would see? And then finally concluded with how to deploy this on AzureML and inference using Onyx runtime. So in this example, we are using the Hugging Face model, which is trained with the Stanford question and answering or the SQuAD dataset. And this one takes a question and it takes a piece of text called context. And then it produces an answer, which is a string of text taken from the context. It tokenizes and encodes the question and the context and feeds the input into the transformer model, and then generates the answer by producing the most likely start and end tokens in the context, which are then mapped back into words. So in this example here, we have, okay. Some of the demo resources, I'll provide a link to it for the YouTube video. There are 2 source codes we'll be using in this demo, and both of them are available in our GitHub repos. And additionally, to run this demo on AzureML, you would need Azure subscription and an AzureML workspace and the access to AzureML UI Studio. So this example is of the Distilbert fine-tune model. There are 2 code files. One is the ds-config JSON file, which is in use to enable the deep speed configuration. And the second code is a fine-tune.py file. And in here, basically, it takes 2 arguments. One is to enable ORT, and another is to enable deep speed. And then the source code for the Hugging Face transformer model that's used is part of that resource. So if you're interested, you can take a look at that from the Hugging Face site. So we load the SQuAD dataset. Again, the dataset is available in the Hugging Face dataset library. And so in the first, we load the model, we load the transformer, and then we convert it. If the ORT argument is specified, we convert it into the ORT module. And then similarly, if the deep speed argument is specified in the JSON, then it enables the deep speed state zero enablement. And then the model training happens. So this is the source code used. Now Razvan will tell you how to create the curated and custom environments.
So right now we're going to see the curated environments and custom environments experience on the UI. If customers would be able to use directly the curated environments, they would have 4 different options depending on various versions of PyTorch, CUDA, and that are part of the packages. For this particular demo, we need some extra packages from Hugging Face, the transformers and the datasets. So in this case, we're going to create a custom environment starting from the curated environment on which we're going to do this package installation. So Parinita is going to show over here. We create a custom environment. We give it a name, which is going to be ACPT demo.
Yeah, so the previous snapshot was what the curated environment would look by itself, and you could easily use that for your training workloads. But as Razvan said here, we need transformers and a few other dependencies, so we are going ahead and enhancing the custom environment.
So we're starting from the curated environment that contains the PyTorch 1.12. Then we're going to add pip installation for several packages, transformers, accelerate, and datasets. And once everything is edited, and we're going to proceed towards creating it.
You can also add tags in case you want your environments to be searchable. We're skipping that step here. And then review and submit.
And now we're going to have a custom environment that is going to be ready for training. So it builds successfully.
So once we have a custom environment created, we can also use that within our training job. So it asks us to select a compute type. You can choose automatic compute or a compute cluster. And then for this model, given GPUs are useful, we'll use that. And then we could choose, for another example, the ACPT curated environment. But we'll go ahead and use the
custom environment that we just created.
And once we have the custom environment, we'll give it a name.
And the next step is to upload the files that Parinita just showed earlier, the fine-tuning and the deep speed configuration, pretty much the entire folder where she had the source code. And we're going to have two experiments over here for comparison. So one is going to be running that fine-tuning script without any arguments. That's going to be the vanilla fine-tuning, so no acceleration from neither deep speed nor Onyx runtime for training.
Yeah. So two flavors. And so here we'll write the command. So you just need to specify Python and then fine-tune.py, which was the fine-tuning script I showed earlier. And if you're running it with deep speed or ORT, you just need to pass those as additional arguments. And if you're running without it, you just submit this as is.
Over here in the create training experience, you would be able to see below that, besides the core training aspects, customers would have the ability to enable interactivity of the job. So they are able to connect with the Visual Studio Code. They can connect to a TensorBoard endpoint. They can actually remote into the container that's running it, pretty much helping the entire experimentation phase.
So we added the distribution type. We added the process count per node after we had applied. And then we review our training job specifications, and then we submit create. So there are two outputs. The first output is the one which was just with the fine-tune.py and no deep speed and ORT arguments specified. You'll see the total training time is around 8,440 seconds, which is 2 hours, 24 minutes. And another run of the same job was with the deep speed and ORT arguments specified. And the total training time there is reduced significantly to 5,044 seconds, which is 1 hour, 27 minutes. So that's a total 1 hour gain in terms of your training job. So imagine if you have to run this over and over again, how much compute resources you would save. So next, we're going to show you how to deploy this trained model on AzureML and inference it with Onyx runtime. So the resources, again, attached with the slides. You could do it through the CLI by installing all of these dependencies. We'll show you how you can quickly, the code for converting to Onyx format is also available here. And then, if you were to run the model with Onyx runtime, that's also shown. All scripts are available in the resource. So here we'll locally convert the pre-trained Onyx model, the pre-trained Distilbert model into Onyx format. And that requires you to run it in eval mode and pass certain inputs and call the torch.export Onyx module. And once we have the local file, then we can also test it locally on our Jupyter notebook just to see that the trained model works well. And so here, you've provided a question called what is Dolly Parton's middle name with some context, and we get the right answer, which is Rebecca. So we know that the model works fine. So now let's see how to deploy this model on an endpoint on AzureML.
So we're going to create a real-time endpoint over here, and we're going to use the Onyx model that Parinita just generated locally, and she had tested. So the first thing is we're going to provide the name for the endpoint. We're going to choose the compute type that we're going to use, and later on in the stage, we're going to actually upload that model. One of the things that we were saying earlier about the entire PyTorch stack is that it's pretty modular, and then customers can come and choose at each point in their ML lifecycle how they want to integrate. In this particular case, we're leveraging the inferencing part as well, not just training as we focused earlier.
To continue with the inferencing, it asks us to register a model. And so we'll browse it locally from the Onyx file that we had created. and upload the model so that the model is registered. And once a model is registered within AzureML, you can use it across various inferencing jobs and deployments.
And one of the other benefits of registering the model is that you would be able to get full lineage of that model. So you're going to be able to see the data set that was used for training. You're going to be able to see the environment, the cluster where it was trained. That helps with reproducibility and traceability for your ML lifecycle. So
we now have a registered model. So the next step is to go ahead with the deployment. We'll go and give it a deployment name. And so as part of, and it asks for a scoring file. So a scoring file essentially has two functions. One is an init function, which is called once, wherein we'll load the tokenizer and we'll call the Onyx runtime inference session. And then a run file, which runs multiple times for each node. And in here, we will basically perform the inferencing task from using Onyx runtime.
Yeah, the run function is executed for every request that goes into the real-time endpoint, and the init one is just when the container gets started.
So we upload the score file here, and then we can select both the ACPT curated environment or the custom environment. Both have Onyx runtime package loaded in it, so inferencing can be performed with either. And then we select the virtual machines that are available within our workspace and provide an instance count and give the amount of traffic we want it to receive and review. And that's it. We have an endpoint ready.
And once the endpoint is created, then you pretty much get an URL that you could hit from a Postman or any of your favorite HTTP clients.
We showed you how to create the file, like convert it into Onyx, how to register the model. Now to invoke the endpoint, you can use the online endpoint invoke command and pass your workspace and configurations and resource group, etc. And that way you can use the model. The other way is also to call using the post URL from Postman. That is it. I think we have a few additional resources available externally. One is the Ignite announcement blog for the Azure container for PyTorch that you can use and leverage for additional details about the container. And then we have some of the other resources I showed you within the demo that you can access. And last but not the least, there is a short survey. There are 6 sweaters to be given. So if you take the survey, there is a chance that you might win a sweater or 2. So please do submit the survey. And thank you for taking your time.
Thank you.